I am deeply saddened to hear about the tragic accident. Electricity can be extremely dangerous, and it is crucial to have proper knowledge and training when working with it. Even seemingly minor tasks can pose significant risks. Here are some key lessons we can learn from this tragic incident. Firstly, electrical safety training is paramount. All workers who handle electricity, regardless of their experience level, must receive comprehensive safety training. This training should cover basic electrical principles, hazard identification, safe work practices, and emergency procedures. Secondly, workers must always use appropriate personal protective equipment, or PPE, when working with electricity. This includes insulated gloves, safety glasses, and flame-resistant clothing. Thirdly, before starting any electrical work, a thorough hazard assessment must be conducted. This assessment should identify potential risks such as live wires, ungrounded equipment, or close proximity to other conductive materials. Fourthly, before working on electrical equipment, it must be properly isolated and de-energized. This means shutting off the power supply and verifying that the equipment is safe to handle. Fifthly, electrical equipment should be properly grounded and bonded to prevent electrical shock hazards. Electrical work should be supervised by a qualified electrician, and workers must follow established safety protocols. It is important to remember that electrical safety is not just about following rules and regulations. It is a mindset that emphasizes caution, attention to detail, and a deep respect for the potential dangers involved. I urge everyone to prioritize electrical safety and to take the necessary steps to prevent tragic accidents from happening. When dealing with electrical systems, understanding the fundamentals is paramount. Alternating current, or AC, is the standard for power distribution due to its efficiency in long-distance transmission. Direct current, or DC, is typically used in electronic devices and some specialized applications. Voltage is the electrical potential difference between 2 points, measured in volts. Current is the flow of electrical charge, measured in amps. Resistance opposes the flow of current, measured in ohms. Ohm's law dictates the relationship between these three quantities. Voltage equals current times resistance, expressed as volts equals amps times ohms. Power is the rate at which electrical energy is transferred, measured in watts. It can be calculated as power equals voltage times current, or watts equals volts times amps. In three-phase systems commonly used in industrial and commercial settings, the voltage between phases is higher than the voltage to neutral. For example, a 208/120 volt system provides 208 volts between phases and 120 volts from each phase to neutral. Similarly, a 480/277 volt system offers 480 volts between phases and 277 volts to neutral. Grounding is a critical safety measure that provides a low resistance path for fault current to return to the source, tripping a circuit breaker or fuse and preventing electrical shock. Bonding connects non-current carrying metal parts of electrical equipment to create an electrically conductive path, ensuring that all parts are at the same potential and minimizing the risk of shock. Personal protective equipment, or PPE, is essential for electrical safety. Insulated gloves are rated for specific voltage levels and protect against electric shock. Safety glasses, or face shields, protect the eyes from arc flash and flying debris. Flame-resistant clothing protects against burns from electrical arcs. Before working on any electrical equipment, a thorough hazard assessment is necessary. This involves identifying potential hazards such as exposed live wires, damaged insulation, and wet environments. Lockout-tagout procedures are crucial for de-energizing equipment safely. This involves disconnecting the power source, locking the disconnect switch in the off position, and tagging it to prevent accidental re-energization. Ground fault circuit interrupters, or GFCIs, are designed to protect against electrical shock by detecting ground faults and quickly interrupting the circuit. They are commonly used in wet locations such as bathrooms and kitchens. Arc flash is a dangerous phenomenon that can occur when a short circuit creates a high-energy electrical explosion. Arc flash can cause severe burns, blindness, and even death. Proper arc flash protection includes wearing flame-resistant clothing, face shields, and gloves rated for the specific arc flash hazard. National Electrical Code, or NEC, is a widely adopted standard for safe electrical installations. It provides detailed requirements for wiring methods, overcurrent protection, grounding, and other aspects of electrical safety. NEC Table 310. 15 provides ampacity ratings for conductors based on their size, insulation type, and installation conditions. These ratings must be followed to prevent overheating and fire hazards. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. They interrupt the flow of current when it exceeds a safe level. Understanding the different types of overcurrent protection devices and their characteristics is essential for proper circuit protection. Electrical safety audits are a valuable tool for identifying and correcting potential hazards in electrical systems. These audits should be conducted regularly by qualified personnel. Proper maintenance of electrical equipment is crucial for preventing electrical hazards. This includes inspecting wiring, tightening connections, and replacing worn or damaged components. Training is essential for all workers who work with or around electricity. Training should cover basic electrical principles, hazard recognition, safe work practices, and emergency procedures. Regular refresher training is also important to keep workers up to date on the latest safety practices. When working with electrical equipment, it is important to always use the right tools for the job. Insulated tools are designed to protect against electric shock. Never use tools that are damaged or worn. Always follow the manufacturer's instructions when using electrical equipment. Working in wet environments increases the risk of electrical shock. Avoid working in wet environments whenever possible. If you must work in a wet environment, use extra caution and wear appropriate PPE. Never touch electrical equipment with wet hands. Electricity can travel through water, so it is important to keep all electrical equipment dry. Always be aware of your surroundings when working with electricity. Look for potential hazards such as overhead power lines, underground cables, and other electrical equipment. If you are unsure about anything, ask a qualified electrician. It is always better to be safe than sorry. Electrical safety is everyone's responsibility. By following safe work practices and taking the necessary precautions, we can prevent electrical accidents and save lives. Remember, electricity is a powerful force that must be treated with respect. Never take electrical safety for granted. Always be vigilant and take the necessary steps to protect yourself and others from electrical hazards. If you see something that looks unsafe, report it immediately. Do not try to fix it yourself. Electrical safety is a continuous process. We must always be learning and adapting to new technologies and challenges. By staying informed and following best practices, we can create a safer electrical environment for everyone. The principles of electrical safety extend beyond specific tasks and equipment. They encompass a culture of safety that permeates all aspects of electrical work. This culture emphasizes proactive hazard identification, continuous improvement, and a commitment to preventing accidents. One important aspect of electrical safety is understanding the different types of electrical hazards. These include shock hazards, arc flash hazards, and fire hazards. Shock hazards occur when a person comes into contact with a live electrical conductor in the path to ground. The severity of the shock depends on the voltage, current, and duration of the contact. Arc flash hazards occur when a short circuit creates a high-energy electrical explosion. The heat from the arc flash can cause severe burns and other injuries. Fire hazards can result from overloaded circuits, faulty wiring, or improper use of electrical equipment. To prevent electrical hazards, it is essential to implement a comprehensive safety program. This program should include written safety procedures, regular safety training, and ongoing hazard assessments. The safety program should also address specific hazards associated with different types of electrical work. For example, working on energized equipment requires specialized training and procedures. These procedures should include the use of insulated tools, personal protective equipment, and lockout-tagout procedures. Working in confined spaces also requires specialized training and procedures. Confined spaces can present a variety of hazards, including electrical hazards, atmospheric hazards, and physical hazards. It is important to identify these hazards and take appropriate precautions before entering a confined space. Electrical safety is not just a matter of following rules and regulations, it is also a matter of using common sense. Always think before you act and take the time to assess the risks before starting any electrical work. If you are unsure about something, ask a qualified electrician. It is always better to be safe than sorry. The electrical system in a building is a complex network of wires, circuits, and equipment. It is important to understand how the system works in order to safely maintain and repair it. The electrical system typically starts with a service entrance, where power enters the building from the utility company. The service entrance includes a main disconnect switch, which allows the power to be shut off to the entire building. From the service entrance, power is distributed to various branch circuits throughout the building. Each branch circuit is protected by a circuit breaker or fuse. The circuit breakers and fuses are designed to protect the wiring from overloads and short circuits. The wiring in a building is typically made of copper or aluminum. The size of the wiring depends on the amount of current it is designed to carry. The insulation on the wiring protects against electrical shock. It is important to inspect the wiring regularly for damage. Damaged wiring should be repaired or replaced by a qualified electrician. Electrical equipment in a building should be properly grounded. Grounding provides a path for fault current to return to the source, tripping a circuit breaker or fuse and preventing electrical shock. It is important to test the grounding system regularly to ensure that it is working properly. Electrical safety is an ongoing process. It requires vigilance, attention to detail, and a commitment to preventing accidents. By following safe work practices and taking the necessary precautions, we can create a safer electrical environment for everyone. Electrical safety is also a matter of personal responsibility. Each individual has a responsibility to protect themselves and others from electrical hazards. This includes following safe work practices, using appropriate personal protective equipment, and reporting any unsafe conditions. By working together, we can create a culture of safety that permeates all aspects of electrical work.